welcome to another module in this massive open online course. So, in the previous module we have seen the spectrum of a frequency modulated signal or an FM signal. In this module let us look at the bandwidth of an FM signal, alright. So, what we want to look at is the bandwidth of an FM signal. Okay. Let the signal be ST equals AC cosine, for instance, for an FM signal which is given as ST equals AC cosine 2 pi FCT plus beta sine 2 pi FMT. Now, the bandwidth of this signal, now the spectrum of this signal we have seen, the spectrum of this signal is given as, the spectrum of this FM signal is given as summation n equal to minus infinity to infinity. Well, AC times j n beta into delta f minus FC minus NFM plus delta f plus FC plus NFM. Okay, so, theoretically if you look at this, this goes from n equals, spans from n equal to infinity to minus infinity. This spans from n equal to minus infinity to infinity. So, it spans from n equal to minus infinity to infinity, that is theoretically it spans, it has a spectrum that spans the entire frequency band. However, that is not practical, since when we have an FM signal we would like to restrict to a certain transmission bandwidth, alright, since the signals are only allocated a certain bandwidth to be transmitted over the air, alright. So, we would like to find what is the practically relevant measure of bandwidth, that is although this is a spectrum that spans minus infinity to infinity, right, typically the frequency decays very fast with increasing frequency. So, we would like to find what is the bandwidth which contains a significant portion of the FM signal, that is a significant portion of the energy of this frequency modulated signal, alright. So, we want to evolve a bandwidth measure or a rule to compute the bandwidth of the FM signal. So, what we would like to find is a rule we would like to find the rule for a bandwidth of FM signal, and this rule which gives us the bandwidth of an FM signal, this is termed as the Carsons rule. This is the Carsons rule. Okay, so, this is the rule which gives us the bandwidth, alright, which helps us evaluate the bandwidth of the FM signal. So, now let us look at the Carsons rule to compute the bandwidth of the FM signal. Carsons rule for bandwidth of an Carsons rule for the bandwidth of an FM signal, alright. Now, this Carsons rule is an intuitive rule, or how do we put it, it is a rule of thumb or an approximation which is valid to a very large degree, alright, which is valid with a very high level of accuracy, alright. And this is based on the following observation, that the bandwidth for large values of beta, that is if you look at large values of the modulation index beta, for large values of beta, the bandwidth approaches delta f. Okay. The bandwidth approaches delta f, where delta f, remember delta f is a peak frequency deviation. Okay. So, for large values of beta, the bandwidth approaches delta f. However, for small values of the modulation index beta, for small values of beta, the bandwidth is approximately 2 FM. So, 2 FM, remember 2 FM is the frequency, or you can think of it as the maximum frequency of modulating signal, is either frequency or maximum frequency. Or the maximum frequency of the modulating signal. Okay. So, what we have seen is that it depends on the bandwidth occupied by the FM signal, significantly depends or majorly depends on the value of this modulation constant or the modulation index beta. For large values of beta, the modulation index basically it is twice delta f, where delta f is the peak frequency deviation. Okay. For small values of beta, it is twice delta f, twice fm, where fm is either the frequency for a sinusoidal modulating signal, it can be simply the frequency of the sinusoidal modulating signal. For a general modulating signal, fm is the maximum frequency, can be thought of as the maximum frequency of the modulating signal. Okay. And therefore, to combining these two principles or combining these two insights, the Carson's rule to calculate the bandwidth of the FM signal is given as follows. So, combining these two principles, so we have these two principles. Okay. Now, we combine these two principles. So, we combine these two principles, Carson's rule of FM signals the Carson's rule for bandwidth of FM signals is given as, well, the bandwidth of an FM signal is approximately equal to twice 1 plus 1 over beta into delta f, where beta, remember beta is the modulation index and delta f equals the peak frequency deviation, equals peak or maximum frequency deviation. Okay, simply this is the maximum frequency deviation of basically the instantaneous frequency from the carrier frequency, the instantaneous frequency FIT from the carrier frequency. Okay. This is the maximum frequency deviation. Okay. So, this is your Carson's rule. This is basically the Carson's rule for FM bandwidth. Okay, just let me just write this here. This is your Carson's rule. Okay. Now, you can clearly see, for instance, if you take a look at this expression, twice 1 plus 1 over beta delta f. Now, for large beta, we have, for instance, if you look at this for large beta, we have 1 over beta approximately equal to 0, which means the bandwidth is approximately equal to twice into delta f, where delta f is the maximum frequency deviation. Alright, so for large values of beta, 1 over beta is approximately equal to 0. So again, this expression reduces to twice delta f, similar to what we have seen in the principles earlier. Now, for small values of beta, for small beta, now what happens is when beta is very small, approximately close to 0, then 1 by beta is much greater than 1, implies the bandwidth is approximately equal to twice 1 plus 1 over beta delta f, which is approximately equal to, since 1 over beta is much greater than 1. So, this is approximately equal to twice 1 over beta into delta f, but remember beta is delta f by fm. So, this is approximately twice 1 over delta f by fm into delta f, which is equal to fm, which is equal to basically fm. Or let me just write this a little bit clearly. So, this is 1 over delta f divided by fm into delta f, which is equal to twice, which is equal to twice fm. Okay. So, this again reduces to the principles that we have seen earlier, that is when beta is very high, that is when for large beta this is approximately twice delta f, for small beta this is approximately twice fm. Alright. So, that is basically a rule of thumb or a very good approximation to the bandwidth occupied by an FM signal, which can be used for to practically, that is which can be used for practical communication systems, alright, based on frequency modulation. Okay. And therefore, now if I can write it also, I can realize that I can also write this as Bt, the bandwidth is twice 1 plus 1 over beta into delta f, which is twice delta f plus twice over beta delta f. Now, delta f over beta is fm. So, this is twice delta f plus twice fm. So, remember this is basically 2 into, that is basically twice the maximum frequency deviation, and this is basically your twice into frequency or maximum frequency of, or max frequency of the maximum frequency of the modulating signal. Alright. So, I can also express this as twice delta f plus twice fm. This is an alternative way, right, alternative way to write the Carson's rule for the bandwidth of an FM signal. Alright. Now, to understand this, let us look at a simple example to compute calculate the bandwidth of an FM signal and see how the Carson's rule can be applied. Okay. So, let us look at a simple example. For instance, let us consider a carrier frequency equals 10 megahertz at delta f equals 50 kilohertz. Now, we would like to determine the bandwidth for FM corresponding to A for FM, that is values of FM, the maximum FM frequency given below. FM equals, well, 5 kilohertz. B, FM equals 50 kilohertz. C, FM equals 250 kilohertz. Now, that is our problem, and the solution can be found as follows. The solutions. Now, if you look at part A, now realize that beta, let us start by calculating beta. Beta equals delta F by delta M. So, what we have is we have given a carrier frequency, alright, and we are also given delta F, that is a peak frequency deviation, and based on different values of FM, that is a frequency of the modulating signal, we have to calculate the bandwidth of the FM signal using Carsons rule. Okay. So, for the first case, let us start with beta equals delta F by FM. We have, which is equal to, well, we are given FM equals 0.5 kilohertz and delta F equals 50 kilohertz. So, beta equals, well, that is your delta F, which is 50 kilohertz divided by FM, which is 0.5 kilohertz. So, beta is equal to 100, which is significantly greater than 1. And therefore, using Carson's rule, since beta is significantly greater than Carson's rule, from Carson's rule, the bandwidth is approximately equal to twice delta F, which is equal to twice delta F is 50 kilohertz, twice 50 kilohertz, which is equal to 100 kilohertz. Okay. Therefore, from Carson's rule, we have the bandwidth, alright, we have the bandwidth of the FM signal. Since beta is very large, beta is 100, which is significantly greater than 1, the bandwidth is approximately twice delta F, okay, which is 100 kilohertz, okay, which is 100 kilohertz. Okay. Now, let us look at case B. In case B, we have delta F equals 50 kilohertz, again beta equals delta F by FM, delta F equals 50 kilohertz, FM is also 50 kilohertz, okay. Delta F by FM, which is equal to 50 kilohertz divided by 50 kilohertz, which is equal to 1. So, in this case beta is exactly 1. So, we cannot use the approximation, which means the bandwidth is twice 1 plus 1 over beta is 1 into delta F, which is 50 kilohertz, which is basically twice into 2, that is 4 times 50 kilohertz, that is equal to your 200 kilohertz. Okay. So, the bandwidth is basically 200 kilohertz. Okay. Now, let us look at the last case, in which FM is equal to 250 kilohertz. Okay. The message frequency. So, therefore, delta F is equal to, delta F is basically 50 kilohertz divided by 250 kilohertz, and that is equal to, that is the, so your beta, or basically your modulation index beta is equal to 50 kilohertz by 250 kilohertz, and that is equal to 0.2 which is less than 1. So, I can use the approximation here that for beta is less than 1, the bandwidth is approximately equal to twice Fm, which is equal to twice into 250 kilohertz, which is equal to, well, 500 kilohertz. That is the bandwidth of the net bandwidth of the signal using Carsons rule. Okay. Of course, here because beta is not very small in comparison to 1, I can also use the exact expression from the Carsons rule. However, since beta is fairly small, one can choose also to use the simple approximation that that the bandwidth is simply twice Fm, alright, where Fm is the frequency of the modulating signal, alright. So, basically this illustrates how the Carsons rule, can be used to compute the bandwidth of a typical FM signal depending of course on the peak frequency deviation, right, the maximum frequency deviation delta f, Fm which is the frequency of the modulating message signal, and also beta which is the modulation index. And in fact, beta plays a key role, that is the level of modulation or the modulation index plays a key role in the net bandwidth that is occupied, or the net bandwidth that can be practically assumed to be occupied by this FM signal in a practical scenario. Okay. So, basically in this module we have seen a practical rule, that is the Carsons rule, to compute the bandwidth of a typical FM signal, which can be used to determine the bandwidth that has to be allocated for this FM signal in a practical communication system. So, we will stop here and continue with other aspects in the subsequent modules.